High above the Earth, a great river of wind circles the North Pole. This is the Polar Vortex. It's a vast cyclone of super cold air, spinning 20 to 50 kilometers above ground, acting as a fortress that locks Arctic cold away. When strong, the vortex keeps the jet stream straight, separating frigid polar air from milder southern climates, giving us stable, predictable winters. But now, that balance is breaking. The vortex is weakening, its winds slowing, its shape distorting and splitting. This lets Arctic air escape, plunging south in dramatic cold outbreaks that can rewrite weather maps in days. The term polar vortex has become synonymous with brutal, unpredictable cold snaps, events that are growing more frequent and intense. As we approach winter 2025, the signs point to another major disruption. Understanding what's weakening this Arctic crown is now essential for our resilience and survival. The main force undermining the polar vortex is a phenomenon known as Arctic amplification, a process that is rapidly transforming the top of our planet. The Arctic is warming at a rate 4 times faster than the global average, a staggering pace that is rewriting the rules of our climate system. As sea ice melts away, what was once a bright, reflective shield turns into dark, open ocean. This ocean absorbs far more solar energy, intensifying the warming and accelerating the melt. A relentless feedback loop that's difficult to stop. The extra heat released from the ocean doesn't just linger at the surface. It rises, destabilizing the stratosphere above and eroding the sharp temperature contrast that powers the polar vortex's fierce winds. As the Arctic warms, the temperature gap between the pole and the equator narrows. This shrinking difference weakens the jet stream and slows the vortex, making it more prone to wild swings and instability. A sluggish, weakened vortex begins to wobble, sometimes even breaking apart entirely, sending ripples through the atmosphere. This instability can trigger dramatic events called sudden stratospheric warmings, where warm air surges into the stratosphere, causing temperatures to skyrocket by as much as 50 degrees Celsius in just a few days. The result is a polar vortex that can collapse or even reverse direction, sending shockwaves through the entire climate system and disrupting weather patterns far beyond the Arctic. Weeks after such a breakdown, the consequences can be felt thousands of miles away, unleashing severe cold outbreaks and extreme winter storms in places unaccustomed to such weather. Arctic amplification is the engine driving this new era of weather chaos, fueling unpredictable and sometimes devastating events across the globe. The fortress of Arctic ice is crumbling, and as it does, the consequences are not just local, they are global, affecting weather, agriculture, and economies everywhere. The polar vortex is no longer a distant curiosity or a scientific oddity. It's a direct and growing threat to our daily lives, shaping the winters we experience and the risks we face. Understanding this powerful feedback loop is essential if we hope to prepare for what's ahead, adapt to new realities, and protect communities from the engine of disruption now roaring at the top of the world. Beneath the polar vortex, the jet stream shapes our weather. When the vortex is strong, the jet stream flows straight, keeping cold air penned in the north, but a weakened vortex lets the jet stream meander, forming deep looping waves, Rossby waves, that can stretch across continents. These waves channel Arctic air south, bringing record cold and snow, while ridges pull warm air north, creating wild weather contrasts. The result isn't uniform cold, but a chaotic mix of extremes: blizzards in one region, unseasonable warmth in another. Slow, wavy jet streams can stall, causing weather traffic jams that turn brief events into disasters, floods, freezes, or heat waves that linger for weeks. The river of air that once brought order now delivers chaos. Our familiar seasons are giving way to unpredictable, stuck patterns. The jet stream's breakdown is a signature of our changing climate. The impact of a disrupted polar vortex is no longer just a scientific theory. It's a reality that has played out in recent memory, with consequences that reached millions of people across Europe. In early 2018, Europe was battered by the infamous beast from the east, a weather phenomenon that was a direct result of a polar vortex breakdown, itself triggered by a dramatic sudden stratospheric warming event high above the Arctic. The polar vortex, which usually keeps frigid air locked over the North Pole, reversed its flow. This reversal unleashed a torrent of Arctic air from Siberia, sweeping across the continent. Temperatures plummeted to record lows, and cities that rarely see more than a dusting of snow were suddenly buried under thick, relentless drifts. The UK and Ireland ground to a halt. Roads became impassable, public transport was paralyzed, and supermarket shelves emptied as supply chains broke down. The economic impact soared into the hundreds of millions, and daily life was thrown into chaos for days on end. This extreme event exposed just how vulnerable our infrastructure and public services can be when faced with rare but powerful cold snaps. It was a stark reminder that even in a warming world, deadly cold can still strike with little warning. Fortunately, meteorologists detected the stratospheric warning signs weeks in advance. Their forecasts gave governments and emergency services precious time to prepare, helping to prevent even greater disaster. The beast from the east was a wake-up call for Europe and beyond, a vivid demonstration that the polar vortex can unleash chaos far from the Arctic, and that early warning systems are absolutely vital for public safety. Today, understanding these stratospheric signals isn't just a matter of scientific curiosity, it's a matter of protecting lives, communities, and economies from the next big freeze. If the beast from the east was a warning, the 2021 Texas freeze was a catastrophe of unprecedented scale. A sudden stratospheric warming event shattered the polar vortex, sending frigid Arctic air deep into the southern U.S., regions built for heat, not cold. The temperature plummeted to record lows, catching millions off guard. Texas's power grid failed catastrophically as natural gas infrastructure froze solid, leaving millions without heat, water, or electricity for days on end. The state was plunged into darkness and cold. The human toll was severe, hundreds of lives were lost, homes were flooded from burst pipes, and the economic damages soared to over $30 billion. The community was left reeling from the disaster. The event exposed how critically unprepared our infrastructure is for the new climate extremes we are facing. It was a wake-up call for the entire nation. Wind turbines, gas, coal, and even nuclear plants failed in the extreme cold, highlighting the vulnerabilities in our energy systems. The Texas freeze quickly became a global case study in the risks of ignoring Arctic change and the far-reaching impacts of climate disruption. No region is immune. A wobble above the pole can trigger disaster thousands of kilometers away, affecting areas that are completely unprepared for such events. The lesson is clear: resilience must replace complacency. We must adapt and prepare for the new realities of our changing climate. The polar vortex's reach is global, and its disruptions are only growing. We must act now to mitigate these impacts and protect our communities. Extreme cold from a disrupted vortex puts modern infrastructure to the test. Power grids, water systems, and transport networks are designed for past climates, not today's extremes. When cold shatters records, systems fail in a cascade. Power plants freeze, blackouts spread, and water treatment grinds to a halt. Roads and runways become impassable, supply chains break, and economic losses mount. The freeze-thaw cycle damages roads, bridges, and buildings, while water pipes burst, flooding homes and businesses. Each event leaves lasting scars, demanding costly repairs and upgrades. The just-in-time logistics of our global economy are fragile in the face of such disruption. Airports close, flights are canceled, and essential workers are stranded. The cumulative effect is relentless erosion of our infrastructure. Massive investment in winterization and resilience is now essential. The future demands systems built for extremes, not averages. The human cost of extreme cold is profound. Hypothermia, frostbite, and surges in heart and respiratory illnesses threaten the most vulnerable. Cold snaps can trap pollution, worsening air quality and respiratory health. Power and water outages create unsanitary, dangerous conditions while the mental toll of isolation and stress lingers. Agriculture suffers. Late frosts destroy crops, delay planting, and drive up food prices. Economic losses ripple outward. Businesses close, supply chains break, and insurance claims soar. A single polar vortex event can erase billions in economic growth. The fallout is not just physical but social and financial. Preparing for these impacts is now a necessity, not a choice. Predicting the polar vortex is now critical for survival. Satellites, weather balloons, and ground-based sensors provide real-time data on stratospheric conditions. Supercomputers run advanced models, simulating the atmosphere and forecasting disruptions weeks in advance. This early warning allows governments, utilities, and emergency services to prepare and respond. The lead time has grown. What was once days is now 2 to 3 weeks. New Arctic observatories and AI-driven analysis are pushing forecasting even further. The The science is clear. Monitoring the stratosphere is our best defense. Early warnings save lives and limit damage. As the climate changes, prediction is our frontline tool. The new normal is a polar vortex that's weaker, wobblier, and more unpredictable. Winters ahead will be marked by wild swings, mild spells shattered by sudden brutal freezes. The gradual, predictable seasons of the past are giving way to weather whiplash. A stuck jet stream can bring a freeze to one continent and drought to another. The ripple effects reach far beyond winter, disrupting monsoons and threatening ecosystems worldwide. Our global climate is interconnected. A problem at the pole is a problem everywhere. Adaptation and resilience are now essential. We must winterize infrastructure, update building codes, and protect the vulnerable. The polar vortex is sending a message. The world is changing. The test ahead is one of foresight, ingenuity, and collective will to adapt.